So in this example, we're going to let u equal e to the 4x, the inner function, which means that y can be rewritten as 3 sine u. So what we do is we let u equal the inner function, u equal e to the 4x, and then we replace, we go back to the original function, this one here, and replace e to the 4x with u. So I rewrite it, but instead of writing e to the 4x, I write u. So that's the first thing. Identify what I'm going to call u, write down what that is, u equals e to the 4x, and then rewrite my original function and replace what I've called u with u. So now, similar idea as we did before, the chain rule, if we look back at it, is telling me to differentiate both bits. So I differentiate u with respect to x, and I differentiate y with respect to u, just using the table of differentials. So I can write down those answers. We've used them many times. Bring the 4 down, e to the 4x. This time there's no number inside this function. It's not 2u or 3u or anything like that. It's just one lot of u. So effectively the sign just changes to a cosine. So we've got 3 cosine u. We write down the chain rule. dy by dx, according to the chain rule, is dy by du times du by dx. Write down the chain rule. So now apply it. This is actually quite easy to do, the differential that we're after, dy by dx. My answer, in other words, is, well, what's the differential of y with respect to u? It's 3 cos u. And what's the differential of u with respect to x? 4e 4x. Done. So this bit, so this bit is dy by du, which is this, and this bit is du by dx, which is this. And finally, I'll replace u with what I set it to be for my final answer. What is u? It's e to the 4x. So dy by dx equals 3 cosine e to the 4x times 4e to the 4x. We wrote. So if we look back to this statement for the chain rule, let's see if we can look at this statement here and apply it to what we've just done. What does it say? Differentiate, ignoring the inner function, and then multiply by the differential of the inner function. So let me show you how to apply that in this case. The original function, let's just write it so we can see it underneath. The original function was y equals 3 sine e to the 4x. That was the original function. And what it's saying is, for this rule, and apply it like this when you've understood it and you've done a few, and in the exam I would recommend you do it as I've laid it out here so I can see your steps. But basically, once you know the chain rule, it's quite easy. What you do is, it says ignore this inner function. And so I'm just going to differentiate with respect to this whole bracket. What's the differential of 3 sine? It's like thinking of the bracket as x. What's the differential of 3 sine x? 3 cos x. So that's 3 cos x, which is that, e to the 4x. And then I multiply that by the differential of the bit I've ignored, which is e to the 4x. So what's the differential of e to the 4x? 4e to the 4x. So just multiply by that. So once you've done a few, you can literally write down the answer, the differential. Ignore what's inside the bracket, just differentiate by of the sine bit, which is 3 cos of the bracket, then multiply by the differential of what's inside the bracket. And that's what the chain rule is effectively telling you to do.